Hello everyone, this is Dr. Jude, and I am doing the recording for your Correlations and Regressions lab. So, before we get started, make sure that when you open this lab, you do a right-click on Blackboard and open in a new window, and then you want to go to File, Make Copy, and name it whatever you want. This will create a copy of it so you can edit it on your own. Next thing on the agenda is to clean this data and explain. So this is Kaggle. Okay, if you click on Kaggle, you'll go to the link. It'll take you to the data set. You get a code book of what the data is about. What this data is about gross domestic product, life expectancy, or more. It's a lot of miscellaneous real data. So this is real data that was collected through multiple countries, and so it tells you what the key features of it are. This is a code book in a way, so you know what you're talking about. What we're going to do for this data set is we're going to use homicide rate as a dependent variable, and we're going to use predictor variables or independent variables, see if anything impacts the homicide rate. What we're also going to do is we're going to choose these variables. What we're doing, this is regression and correlation. So correlation is a bivariate process, but regression is a multivariate process. So the first thing we're going to do is we're going to take a look at the data, look it across, and we can see our country names here. What we're going to do is we're going to right-click, copy this, and we're going to create a new tab, and we're going to call this the Analysis tab. Analysis. And then we're going to just paste that over. The second thing we're going to do is, because we're using homicide rate as our dependent variable, we're going to find the data for homicide rate. Where are you at, homicide rate? GDP, refugees, fertility, secondary era education, population, threatened, GDP growth, primary school, post-life expectancy, forested area. There's a lot of data here. Homicide rate, here we are. So let's go ahead and take homicide rate, copy that, paste it right here. Okay. Now we're going to pull up a bunch of independent variables. So we're going to hypothesize that unemployment rate impacts homicide rate. We're going to hypothesize that what is this? Employment services. I'm not too interested in employment industry, urban population growth. Let's take a look at the urban population growth. We'll do that. Paste that out. And then we'll look at here. What's this? Employment, agriculture. We're not worried about that. Just for fun, let's take a look at forested areas, because why not? We'll look at life expectancy. We got 1, 2, 3, 4. We'll get 2 more variables. Infant mortality, GDP growth, threatened species, population, urban population. We'll take a look at what the percent urban is for this. Because we have forested areas and urban areas, that should go against each other. And one more variable. We'll look at internet users. So here's our 5 variables. Now the next thing that we're going to do is we're going to get rid of any data that has blanks in it. Or more or less, we're going to choose a bunch of countries that don't have blanks. So I guess what we need to do is actually copy this over into a new sheet, paste it, and we'll call this the data for analysis. And then we'll keep the analysis tab. So what we're going to do is we're going to delete our analysis tab now that we've copied that over. We're going to go through here and we're going to find countries that don't have blank spaces here. The first one that comes to mind is the United States. It should have complete data. It does, in fact, have complete data. So on the analysis tab, it's going to move the United States over. Now what we're going to do is, I accidentally pasted that in the wrong row. Let's go up and get the labels up here because the labels are important. Make sure you take the labels over like so. There we go. So United States for the first one. Let's see. Argentina looks pretty good, so we'll take Argentina over. We're going to do 10 countries. So we got 2 so far. Canada should be pretty good. Let's take a look at Canada. Is the Congo good? Yeah, let's bring the Democratic Republic of the Congo over. Estonia. It's Estonia. That's good. Let's go grab Japan. And let's get China and Russia as well. China should be up here. China, Russia, all the way down here. Where you at, Russia? QRS. Russia. 2 more countries. 1, 2, 3, 4, 5, 6, 7, 8. 2 more countries. Iraq. And then finally, we'll do Egypt. A lot of variation in our countries. Alright, so here we have it. Egypt has almost no forested areas. Naturally, it's in the middle of the desert. So, alright, now here's what we're going to do. We're going to run analysis. Let's see what the highest homicide rate is. Iraq, Russia, Argentina, and the U.S. Those are the highest homicide rates. Something to take note of. Now, what we're going to do is we're going to open up our, you should have this already installed through other labs, but your Excel minor analysis toolpack. Start that up. We're going to run correlations, and our input range is going to be homicide rate all the way to internet users. So go ahead and just highlight that and then click it in the blank. It should fill out. In our output range, we're going to tick labels. And our output range is just going to be right below it. And then hit OK. You get a correlation matrix out of this. All right. So here our dependent variable is our homicide rate. We're going to see how all these variables impact it. So according to this, homicide and unemployment don't really seem to have much of a relationship. It might be because of the, God, yeah, Egypt's really throwing that one off. See that? 2 homicide rate with an unemployment rate of 10. Otherwise, I think, anyway, it's just not showing a relationship at all. It's negative 0.02. So we don't see anything in the unemployment. We don't see too many relationships at all, except for forested areas. And but that is what it is. We're just doing a model here. We're not looking for like super great results. But anyway, if you read a correlation, it is anything. It goes from -1 to +1, and the closer you get to -1 or +1, the stronger the relationship. In this case, -0.3 is the strongest relationship we have on it, and everything else is like under 0.1. So there's not really anything interesting going on in correlations, meaning there's probably not going to be too many interesting things going on in regression either. But this is your correlation matrix. You can report that there is a weak relationship, saying that as homicide rate goes up, forested areas go down. In other words, you start seeing more urbanization, right? The more urbanization that happens, the higher your homicide rate gets, is what that's saying. And although we don't really see that show up in urban population. Next, we will do a regression analysis, so just hit OK with that. what we're going to do is pull up your linear regression, and our input range, y range, is our dependent variable only, so we're going to highlight our dependent variable, which is homicide rate. Click that. And then we're going to highlight everything else, because these are our predictor variables or independent variables, and put that in the X range. We're going to hit labels, make sure the labels are on, and our output range is going to be right below our correlation matrix. Hit OK, run those numbers. Input range contains non-numeric data. Alright, let's see. Do we not have labels ticked? Oh, there is a blank here. Congo's blank on it. Oh, that's what threw it off. Well. Alright. Well, I'm just going to put in a number here of the Congo. Put 5.2. I didn't even see that. So let's just rerun this correlation. Run the correlations. And just rerun that. Now we start, and now we see a good relationship. That blank really, that's the difference that's the reason why you don't have blanks, and it threw the relationship completely off. So now we actually see a relationship between unemployment and homicide rate. Actually, that mistake might be something that's quite clear now. But we have that 0.51. That means there is a strong relationship between homicide rate and unemployment. We also start seeing, a relationship between urban areas and forested areas, as expected. The higher the urban population, the more homicide rate is, and the lower the forested rate areas. This is the same thing. It's kind of cool that it came out almost identical. So the higher, because it's positive, the higher urban population, the higher the homicide rate. And this is forested area. The higher the homicide rate, the lower the forested area. So as forested areas increase, homicide goes down. Or as homicide goes up, forested areas go down. We don't really see too much in the life expectancy, urban population, or internet users area. Now let's go ahead and run the regression. We have the same ranges that we just put in earlier. Hit OK. It should generate this time. There it is. Lots to read here, but it's okay. One, this is significant, so the model is good. It's under 0.05. Model is good. You see our multiple R squared. Model is good, well correlated. So far, the model is working. Let's take a look at our first thing we should look at is our p-values on all here. And I'm going to highlight all the ones that are significant. This is significant, meaning the model is significant. So the model is something that we can trust. This is not significant, so I'm going to color it like a blue. Not significant, not significant. Same blue color, if I can remember which blue color I assigned to it. This is significant, so we're going to highlight this yellow, and this is significant. So we have that. This almost made it. Almost made it. Not quite, though. So let's go ahead and read this model. First, we will pay attention to our intercept is significant, meaning the model works that does call it out. So our life expectancy, that makes sense. So as our homicide rate increases, our life expectancy decreases. For every 1 point of homicide rate, for every 1 point added to our homicide rate, we lose 1 year in life expectancy. That makes a whole lot of sense if you think about it. So we'll go ahead and highlight this in yellow. And the next one is internet users. Now this is something that we don't really think about, right? As our internet users increase, we see a small uptick, a 0.15 uptick in homicide rate. So for every 1% internet user increase that we see an uptick of 0.15 into our homicide rate. So what this is saying is the more internet users we get, we start seeing a small increase in homicide rate. This is how you read a regression analysis. And when you report this way it would look is, hey, the model is significant. This is how you tell if the model is significant. That p-value right here, the one that says intercept, and the p-value up here will tell you if the model is significant or not. They need to be both significant p-values to be a significant model. And then you can say life expectancy and homicide are related. we can say that internet users and homicide are related. For every 1% increase in homicide, we will see a negative 1.05% decrease in life expectancy. Yep. Now, do not confuse this as it's always a percentage, okay? So do not do that. The reason why these are in percentages is we chose nothing but rates for our model. Now, if we were using whole numbers, it would be something like, let's say that life expectancy was in years instead of rates. And homicide was in a count. Let's say it was like 50,000 homicides in the country. Then we could say things like, for every 10 homicides, we can see a 1-year decrease in life expectancy kind of deal. Next is our internet users. For every 1% increase in homicide, we'll do it that way because it makes for every 0.15% increase in internet users, we can expect to see a 1% increase in homicide. And that's all there is to it. That's how you do this lab. Go ahead and do this on your own, and then submit it into the lab portal. I will see you next time.